As Ada said, I will be talking about reconciling food security and emissions in a changing climate, and we'll talk a bit more about our part of the project where we looked in depth into climate change impacts of main food products, and my presentation will mainly focus on wheat. So the food systems are facing a triad of challenges. One is the rising food demand, which is due to population growth, changing lifestyles, economic development, which in the end actually will push up emissions. Another challenge is that we need to reduce emissions from the food sector. So about 30% of the EU emissions are associated with the food systems, and about 14% are associated with agriculture. And these mainly, as Alice already pointed out, occur from natural processes and are non-CO2 emissions. So they're much more complicated to control and much harder to reduce. And the third challenge is that we need to adapt to climate impacts. And it is projected, as Alice already mentioned, that in higher latitudes, it's likely that we have some benefits from climate change, like yield improvements. But in lower latitudes, we are facing worsening conditions. And these are actually also regions where the food demand growth will be highest over the next decades. So there's a challenge that food supply, emission reductions, and adapting to climate change are contradicting and often conflicting. So in our project, we looked at wheat and its emission under different impacts and production options. So the graph you see here shows you emissions occurring from producing 1 kilogram of wheat grain. The baseline shows you that the major part of the emissions here is occurring from the soil, and the other major share is from producing nitrogen fertilizers, while the small part of the stack is mainly due to agricultural activities, producing other inputs and transportation and so on. So we assumed that within a 2-degree scenario, the UK's wheat production can increase yields during the next decade by about 25%, which on the other hand also requires higher inputs, especially nitrogen fertilizer. So this column shows you the emission intensity of 1 kilogram wheat grain, and it also shows you that it's quite similar to today's emissions, to the baseline, which is because the higher yields are offsetting the higher emissions from, or the emissions from the higher input. So the emissions per unit of output do not significantly change within this scenario. But if you look at the table, you see that this number actually increases because more wheat is produced. And now the question is, why should the UK produce more wheat? Well, one thing is that wheat production in the UK will be more efficient than in some other parts of the world, and especially compared to regions in lower latitudes, which are also likely to severe higher demand growth. And also the production in the UK is likely to be less emission intense compared to other regions. So with a 4-degree pathway, we assume that even more inputs are needed to maintain the high yields. So, and this you can see from this column, that especially, again, the emissions associated with nitrogen fertilizer and soil emissions are increasing much further. And from the point of global food security, in a 4-degree world, other regions will be even more dependent on production in regions with higher yields and lower emission intensity. So that actually means, from a food security point of view, the UK might need to produce more wheat, even on the price of higher total emissions. We also looked at 2 options how to reduce emissions. And the most significant reductions could be achieved under use of nitrogen inhibitors, which inhibit, as the name says, activities of soil bacteria and reduce nitrous oxide emissions. So from this, we could see that the emissions could significantly be reduced, especially the green bit, which is the emissions from soil. And we only looked at the baseline in the 2-degree scenarios because we can't really tell what happens in the 4-degree world, how soil organisms behave in even higher temperature. So climate impacts can severely threaten food security. And, the food production in some regions is likely to benefit from climate change, like the UK. They then need to take up the responsibility to increase their production. But under a production-based approach, this will, in the end, push up the emissions of the UK. And so a consumption-based approach would highlight how consumer and producers' nations are linked and where emissions, in the end, are produced and consumed. But nonetheless, there's a need for strategies to reduce emissions, to minimize agricultural inputs, and to optimize land use. And from our scenarios, you will be able to see that in some scenarios we are able to lower emissions, but that under a more severe climate change, it is even harder to reduce these emissions. So our key messages are that there's this triad of challenges by raising demand, reducing emissions, and the need to adapt to climate impacts. And global food security will even more depend on countries benefiting from climate change. And decreasing production emissions are possible, but the total emissions is likely to increase in producer countries. But a consumption-based approach would highlight how consumer and producers' nations are linked.